Hello all and welcome back to the Basics Academy channel. In this video, we are going to solve the problem unique number of occurrences. The problem statement is given an array of integers, return true if the number of occurrences of each value in the array is unique or false otherwise. Let us go to our AI Socratic interviewer, paste the question and get started.
All right, let's start. Here to it. That's the problem. Is that What is this problem actually asking you to determine?
It is asking to determine the count of individual elements in the array must be equal to the number of elements in the array. Sure. The output is true. Explanation. The value 1 has 3 occurrences, 2 has 2, and 3 has 1. No two values have the same number of occurrences. Okay. It is asking to determine the count of individual elements in the array must be unique.
That's the core of it. You count how many times each distinct value appears, and then those counts themselves must all be different from one another. Good. Quick check on that third example, the one with the negative threes. Can you walk me through the occurrence counts there and tell me why they're all unique?
Okay. The occurrences of all elements from the array is as follows. First is minus 3. Minus 3 appears 1, 2, 3 times. Then we have 0. 0 appears 1, 2, 2 times. Then we have 1. 1 appears 1, 2, 3, 4. 4 times. Then we have 10. 10 appears 1 time. Hence it returns 2.
Exactly right, counts are 3, 2, 4, and 1, all distinct. So true. Your understanding is solid. Let's nail the input-output contract. What's the exact type of the input and what exactly does this function return?
Input type is an array and output type is a boolean.
Correct, input is an array of integers, output is a boolean. Contract str. Now the constraints. Look at the array length and the value range. What do those two bounds tell you? And does anything there hint at how you might solve this efficiently?
constraints array dot length is greater than 1, less than 1000. Array of phi will range from minus 1000 to 1000. Look at the numbers given, array length and the value range. What do those two bounds tell you? And does anything that hint at how you might solve this efficiently? Okay. If the array length is going to be 1000, mm, we can directly loop the array as the length is going to be anyways less than or equal to 1000, and the elements are anyways going to be 2001 starting from minus 1000 to near 1000.
Good read. Length up to 1000 means even a somewhat expensive pass is affordable, and values live in a small bounded range of about 2000 possibilities. That bounded range is a real hint. Before we design anything edge cases, what inputs would you want to make sure your solution handles correctly? Give me a few in plain English.
It should handle negative numbers. It should handle FTL. No. It should handle arrays with only one element. These are the two edge cases, I would say.
Both valid single element arrays and negatives are worth flagging. But those are input shaped edge cases. Is there a logical case that's the whole point of returning false? Think about the smallest array that gives false.
Yes, if the length of the unique elements is not equal to keys, if the length of the unique elements is not equal to the key's length of the frequency counter, then we should return false.
You've actually leaped ahead to the optimized approach. That's fine, we'll go there, but I want to pin down your wording because, as stated, it has a subtle trap. The keys of your frequency counter are the unique elements, so those two counts are always equal, and that check would never fire. What are the two quantities you actually want to compare?
What two things should you be comparing? Number of unique elements with count of the unique elements.
You are circling the right idea, but the nouns keep sliding. Let me anchor it. Your frequency map has keys, the distinct values, and values the counts. It's those counts, the max values, where a duplicate causes a false. So focus only on that list of counts. What's a clean, standard way to check whether a list has any duplicates in it?
We can make use of set to check if the list has any duplicates.
There it is, a set. Now finish the logic. Once you drop all the counts into a set, what comparison tells you whether there was a duplicate?
Once we drop all the counts to the set, if there exists a duplicate, then the size of the set may be less than the size of the map, which would then decide to return false.
That's precise and correct. Set size less than map size means a collision, so false, otherwise true. Equivalently, return whether those two sizes are equal. That's your whole optimized approach. Last thing before you code, give me the time and space complexity of this approach and justify each one.
Time complexity will be big O of n, since we are creating a map and counting the frequencies of the array elements, which in the worst case, not worst case, which will run for all array elements, then space complexity will again be big O of n, since we are storing a map for all distinct elements.
Both correct. Time is order and one pass to build the frequency map, then a pass over the counts to build the set, all linear. Space is order n for the map and set when every element is distinct. Pre-flight's done. Now write the actual JavaScript. Code it out loud as you go, and I'll hold my feedback until you tell me it's your final answer.
Okay, so this will be the function const unique occurrences, which takes an input as array. And first, step 1, we will count the frequencies for each element and store them in the map. The map will be defined as const counters equals new map. Then you will run a for loop for let I equal to 0, I less than arr dot length I plus plus. Here we will set counters dot set arr of I. This will be set to first we'll get counters dot get array of I if it exists or 0, then that will be added with +1. So this will count all the frequencies for all the array elements. Once they have this, then in step 2 we will create a set of the map values or frequencies. How to do that? So const map values is equal to new set. Here we will pass counter dot values. Once we have counter dot values, and at last we return counters dot size is equal to map values dot size. End of function.
Okay, final answer, let's review. Your logic is sound. But before I grade it, trace step 2 for me, variable by variable. Read that line out loud. Does every name you reference there actually exist?
Counters dot set, counters dot get, arr arrange there, then map values is equal to new. Okay, so here it should be counters dot values.
That's the one. You referenced counter, singular, but you declared counters. That's a reference error at runtime. The function crashes before it returns anything. Good catch when you traced it. One more thing before I grade the function name. You wrote unique occurrences. Compare that letter for letter against how the word occurrences is actually spelled. Does anything about the name concern you for a lead code submission?
It should have been two hours.
Correct unique occurrences 2RS. The grader calls your function by its exact name, so a misspelling means it can't find your function at all. Two separate name bugs, both fatal to a submission, both caught only on a trace pass. Here's the verdict 7.5 out of 10. Optimal approach, correct complexity, clear communication, but two name bugs that would each fail the submission. Caught only when I told you to trace. Your one improvement, run that trace pass yourself before declaring final every time. Now the reflection. First question, looking back, what clue in the problem statement itself most directly pointed you toward counting frequencies, then checking those frequencies for duplicates? What was the tell?
Prior to this, let us go to lead code. I have already solved this problem. Here it is. We have unique occurrences. First, we create a map. Then we get the frequencies of individual elements from array. We set the different frequencies. After setting the different frequencies, we create a set from the counter values. This will add only the distinct elements. If two elements have the same count, the set will have one less element. At last, return counter.size is equal to set.size. When we return this returns whether all the elements in the array have unique occurrences. Let us run this. Done. All three test cases are passing. Now let me submit this. Yes, our code runs in 0 millisecond of time. Now going back to our AI Socratic interviewer, what was the tell? The tell was unique occurrences.
Exactly, and notice how cleanly it decomposes. Occurrences means count frequencies, unique means check those frequencies for duplicates. The two-word title literally is the two-step algorithm. Next question, zoom out from this specific problem. What's the reusable pattern here? The general technique you'd now recognize in any future problem with this same shape.
For frequencies, use hash map, and for getting unique values, use set.
That's the right pair. Generalize it so it transfers. A hash map is your reflex. whenever you need perky counts. The set plus a size comparison is your reflex whenever you need to detect duplicates. This problem is just those two composed count hyphen slash then dedupe check.
TD.
Next, put yourself in the interviewer's chair. Your approach was clean and optimal, but your code had two name bugs that both crashed the submission. In a real interview, how would that land and what would it signal to the person evaluating you?
It would signal to the interviewer that I am in a hurry to code completion and not taking into consideration the importance of dry running the code.
Right, and here's the nuance. Your thinking was strong and your approach optimal, so the bugs don't read as can't solve it. They read as a verification gap you declared done before validating. That's a discipline fix, not a knowledge gap, but unchecked it fails you on an otherwise passing solution. Last question, concretely, what will you do differently on the very next problem to close that verification gap? The specific habit, not a vague, be more careful.
Dry run the code before seeing it's done.
That's the habit and make it mechanical. Before the words final answer leave your mouth, pick one concrete input and execute your code line by line as literally written, touching every variable name. It costs 30 seconds and saves a failed submission.